The idea of time travel has captivated humanity for centuries. Imagine witnessing the birth of a star, walking with dinosaurs, or glimpsing the distant future. This isn't just fantasy, it's a deep human longing to break free from time's relentless march. We dream of correcting mistakes, reliving cherished moments, or peering beyond our lifespans. Ancient myths are filled with heroes who sleep for centuries or glimpse the future, revealing our obsession with time. From H.G. Wells' The Time Machine to Doctor Who, our greatest stories explore the what-if of time travel. Why does this idea grip us? Because time is both our gift and our greatest limitation. The past is a museum we can't revisit, the future, a locked room. Time travel promises a way to transcend this linear path, a hope that we might one day become navigators, not just passengers. This dream fuels both our art and our science. The greatest minds have wrestled with the nature of time. Is it a universal clock or something more personal and malleable? The quest to understand time is the quest to understand the universe itself. It pushes us to the limits of knowledge and forces us to confront the deepest mysteries of existence. So let's step into our ship of the imagination and explore the science, paradoxes, and mind-bending truths of time travel. The cosmos awaits. Before we talk about time travel, we must ask, what is time? Newton saw time as a universal, unchanging river, absolute and constant for everyone. This idea matched our everyday experience for centuries. But Einstein shattered that view, proposing that time is woven with space into a four-dimensional fabric, space-time. Space-time isn't flat or rigid. It bends and warps with mass and energy. There's no single universal clock. Time is relative and personal. Your clock's speed depends on your motion and the gravity around you. For example, a fast-moving spaceship's clock ticks slower than one on Earth. This isn't science fiction. It's a proven property of our universe. So time travel isn't about jumping into an invisible river. It's about navigating the dynamic landscape of space-time. The rules are set by relativity, not by a steady tick-tock. Time is an active participant in the cosmic dance. Understanding this is the first step toward choosing our own destination in time. It changes everything. Time is relative. It can be stretched and squeezed. Einstein's relativity shows us how the faster you move, the slower your time passes. This is time dilation. Imagine the twin paradox: one twin stays on Earth, the other travels near light speed. The traveler returns younger. This isn't just theory. Astronauts age microseconds less than us on Earth. Gravity also bends time. The stronger the gravity, the slower time flows. A clock at sea level ticks slower than one on a mountain. GPS satellites must account for this, or their data would be wildly inaccurate. Traveling to the future is scientifically possible. Go fast enough, or near something massive, and you leap ahead in time. Orbit a black hole, return to Earth, and thousands of years could have passed. The journey is extreme, the technology far off, but the physics is sound. The door to tomorrow is open, even if just a crack. We're all time travelers moving into the future at 1 second per second, but with enough speed or gravity, we could jump much farther ahead. The future is, in principle, within reach. But what about the past? Traveling to the future is possible, but going back is far trickier. The universe seems to prefer moving forward. Eggs scramble, glasses shatter, but not the reverse. This arrow of time is tied to entropy. Systems move from order to disorder. To travel backward, you'd need to twist space-time into a loop, a closed time-like curve. Wormholes, or Einstein-Rosen bridges, are one theoretical way shortcuts through space-time. If you could manipulate a wormhole's ends, you might connect two different times. But keeping a wormhole open would require exotic matter with negative energy, something we've never observed or created. The equations allow for these tunnels, but nature may have a strict no-entry policy. The past remains a forbidden country. For now, the door to yesterday is locked. But what if we could open it? Suppose we build a time machine and open a gateway to the past. We immediately face paradoxes, like the grandfather paradox. If you prevent your grandparents from meeting, how were you born to go back? Or the bootstrap paradox. An object or idea loops through time with no clear origin. There's also the predestination paradox. Your attempt to change the past only ensures it happens. These aren't just sci-fi headaches. They challenge our understanding of causality. If effects can precede causes, the logical foundation of the universe crumbles. Many physicists see these paradoxes as evidence that backward time travel is impossible. The universe may have rules to protect itself from such contradictions. Paradoxes aren't just fun, they're warnings. The past resists tampering. But could the universe find a way around these puzzles? If backward time travel were possible, how might the universe avoid paradoxes? One idea is the Novikov self-consistency principle. You can travel to the past, but only in ways that don't create contradictions. Try to change history, and something will always stop you. Probability itself conspires to keep the timeline intact. Another solution is the many worlds interpretation. Every action creates a new, parallel universe. Kill your grandfather, and you branch into a timeline where you were never born, but your original timeline remains unchanged. You can't return to it. You've created a one-way ticket to a new reality. Stephen Hawking proposed the chronology protection conjecture. The laws of physics prevent time travel by destroying any would-be time machine with a burst of energy. It's as if the universe has an immune system to protect causality. Whether through self-consistency, branching realities, or cosmic safeguards, the universe seems determined to keep its history safe. Paradoxes may be nature's way of saying, not so fast. The timeline, it seems, is fiercely protected, but our fascination with time travel endures, and it shapes our culture in profound ways. Long before Einstein, humanity traveled through time in stories. Ancient myths told of mortals who returned home to find centuries had passed, early explorations of time's mysteries. H.G. Wells' The Time Machine gave us the first scientific vision of a time-traveling device. Since then, time travel has become a staple of books, TV, and film, from Back to the Future's DeLorean to Doctor Who's TARDIS. These stories let us play with consequences and paradoxes in a safe, fictional space. They ask, if you could change the past, should you? What responsibility do we have to the future? Through these narratives, we wrestle with fate, free will, and destiny. Our stories are thought experiments helping us understand our relationship with time. Time travel remains one of the most powerful and timeless ideas in human culture. It's a testament to our enduring quest to understand the past, present, and future. So, will humanity ever build a time machine? Traveling to the future is theoretically possible, but the technology is far beyond our reach. The energy required is staggering, the engineering, unimaginable. Traveling to the past faces even greater obstacles. Exotic matter, paradoxes, and the universe's own safeguards. The past appears to be a locked room, and we have yet to find a key. But the quest continues. Scientists probe black holes, quantum particles, and the origins of the universe for clues. Perhaps the true value of dreaming about time travel is what it teaches us about ourselves and the cosmos. It forces us to confront the deepest questions of existence and our place in the universe. Whether or not we ever master time, the journey to understand it will always inspire us. The adventure continues, into the future and beyond.